Welcome to the Interop, the show which is all about understanding the decentralized economic networks that make up the interchain. My name is Sébastien Couture. I'm here today with Christopher Goes, who is research and development lead at Heliax and co-founder of Anoma, and has also done a lot of work and was kind of leading the work on IBC for many years. And we bumped into each other last week or 2 weeks ago now at Amsterdam, and we're having a conversation, and I was like, I just want to get this on the podcast. So this is the extension of that conversation. Hey, Chris, thanks for joining me.
Thank you. Pleased to be here. And there's a podcast called The Interop now. I mean, that's amazing.
Yeah, that's true. Yeah, I mean, like the Interop is very much my attempt to understand some of the really technical, deep sort of like technical bits of like how all this stuff works, because I feel like I have a high level understanding of like how IBC works and like all of these interoperable blockchains, but I want to dive deep, and this is what we're going to do today. So this episode is not for the faint of heart, but hopefully we'll make it you'll make it intelligible for people, which I'm sure you do, because I think like you're one of the most articulate people in the crypto space. I've told you this before. Like, every time you're speaking somewhere, I try to go see one of your talks because it's always so like crystal clear.
That is a high standard to start this podcast off with. I hope that I can only hope to match it. Yeah.
Cool. So yeah, let's. For listeners who maybe aren't familiar with your work, what have you been doing the last couple of years?
Right. Well, I sort of kind of randomly, first blockchain project I worked on was, first serious, long-term thing I did was to work on Cosmos. I'd done a little bit of experimentation on Ethereum before. And I originally joined Cosmos because I liked the idea of interoperable blockchains. To me, sort of blockchains were separate sovereign zones, and people would want to operate their own blockchain and sometimes interoperate. And in order to do that, you need a protocol, which makes that easy. So I joined Cosmos to work on IBC. Originally, when I joined, I talked to Ethan, and he said, like, oh, yeah, you can work on IBC. Just help us launch the blockchain. It'll take only 2 months. Then, of course, a year later, we had launched the blockchain. I kid, but it actually was a year, but I kid about the being salty about it part. But then I got to work on IBC, which was lots of fun. And since then, IBC required, of course, solving some technical interoperability challenges. It also required solving some organizational interoperability challenges, which, seemed to, in some ways, mirror the technical ones, except they were more difficult. So originally, of course, I worked at All in Bits, and then the engineering team of All in Bits decided that it needed to be its own sovereign interoperable zone. So we spun out into Interchain GmbH, which I worked at for a little while and is still doing fantastic work on the Cosmos stack. But last year, I parted ways on very good terms with Interchain GmbH to work on Anoma, which is a kind of reimagining of I would describe it as a reimagining of the architectural stack with privacy and heterogeneous security in mind, but with a somewhat sort of an interoperable but somewhat different take than the Cosmos philosophy. Ooh, I think you're muted.
Sorry. So heterogeneous security is a term that I had not heard before we chatted last week, and so I've been kind of doing some research there, and realized that some of the people that are doing most of the heavy lifting in research in terms of research on these algorithms like heterogeneous Paxos are actually working with you at Anoma, or I guess Heliax, which is the company that is building Anoma. So that was pretty exciting, and hopefully we can get I think his name Isaac Sheff. That's right. Is on your team, and he's leading a lot of the research work on heterogeneous Paxos.
That's right. I mean, I consider the best part by far of founding a company is that I get to like hire all these people who are way smarter than I am, and I get to like ask them questions, and they answer all day long. And I just try not to ask like super dumb questions, but somehow it works out.
Yeah, similar to doing a podcast. So like, okay, let me start with this. Like, what's the vision for Anoma, and perhaps for people, because it's not easy to understand. Like I listened to this episode you did with Federica and Brian on Epicenter, and I feel I walked away from that episode understanding a little bit more of what you guys are doing, but it's still not 100% clear. So I think understanding the vision and maybe how it departs from what people are typically used to. So, for instance, like the Cosmos vision or like the Ethereum vision might be useful.
Right. And two, I was joking at an Amsterdam event 2 weeks ago that Anoma is like a zero knowledge project, not only in the sense that we use zero knowledge, but that we can't actually say what Anoma is, but we can give like zero knowledge proofs that this particular component is part of Anoma, and then there's some code, right? Okay, so jokes aside, one reason why it's a little bit difficult to explain the project is that, oh no, I lost you.
I'm still here. You're just full
Oh,
screen.
you're still here. Okay. One reason it's a bit difficult to explain the project is that Anoma is designed with a very different basic philosophy than a lot of current blockchain projects. Not necessarily, it's not a normative judgment. I'm not saying it's better or worse. It's just different. A lot of blockchain projects are designed with a sort of, I would call it a like architecturally incrementalist proposition. So, like, say Zcash is like Bitcoin, except it's private. Or Ethereum is like sort of a Nakamoto consensus, proof of work chain, Bitcoin, except it's programmable, right? And then some other chain is like, Ethereum, like say Near is like Ethereum, but it's sharded and uses WASM or something. There's a sort of X but Y aspect to this.
Yeah.
And that's great. Like it's a clear definition of the project, and it provides for this kind of iteration on different kinds of blockchain architectures. But I think where it falls, where you might want another philosophy is that to users of a system, they care about what they can do with it. Like technology is a tool. And so Anoma is sort of very, like, you could call it architecturally anti-maximalist, which sounds strange because there's a lot of architectural complexity, but there's no one specific thing. So it's not like Anoma is not X but Y for any X or Y. It's just not that. So it's hard to explain in a condensed form of that nature. But instead, like the design philosophy we take is approaching the problem from the reverse direction. And to approach the problem from the reverse direction requires that we like talk about what a blockchain is for in the first place. Like, why would we conceivably want this system? And different people, now it's like there's a large blockchain space, right? It's unfortunate the term I'm using to refer to it is like the name for a particular data structure, which really has little to do with anything. Many blockchains are no longer like literally chains of blocks, right? But how would we delineate, what is a blockchain, or what is like an interesting design philosophy here, as opposed to just spreadsheets or other sorts of companies? To me, at least, it is that you have some kind of database over which you have consensus that is resilient to Byzantine actors. And why would you want such a database in the first place? It would be probably only because you somehow care about what data is being stored on it, which sounds kind of abstract, but let me compare by example. So in the world right now, we have this like interesting concept of money. And we have a bunch of basically Excel spreadsheets, and COBOL files and whatever it is that Deutsche Bank uses, I don't want to know, that describe who has what money. And we've, collectively, for better or for worse, decided to architect a lot of our societal processes and decided to render, survival in many senses contingent on possession and use of this abstraction in money in certain ways, right? But that's a database system. It's even a distributed database system. Unfortunately, though, it's a distributed database system with properties that are kind of unclear and with a lot of points that seem to be captured or vulnerable to capture. So in designing blockchains, at least in my view, what we're really designing are kind of distributed database systems where we can more clearly reason about the properties and where we can provide end-to-end guarantees of the users of those systems that some of those properties are respected, either because they can verify it directly or because we can articulate a trust model, which they can like directly check, right? Like they can say that they're using a proof of stake chain and know that they need to trust 2/3 of the validators. Then they can like talk to 2/3 of the validators, right? So that's legible or verifiable end user trust model that is not available with the current financial system, say. And to me, that's like the interesting design question. So taking that in mind puts the design philosophy of Anoma on a different footing, which is let's start with like users caring about the state of this system. And the way we choose to represent that in Anoma is called an intent. You can think of an intent kind of like a generalized order, or you can just think about it as a statement of preferences. So an intent is a way for a user of the system to say, I would like the system to be this way. Like relative, it can be absolute, or it can also be relative to the current state of the system. I would just prefer this other state. And the role of all of the sort of blockchain infrastructure is to facilitate two things. One, is to facilitate one thing, which is split into two phases. The one thing is simply enacting Pareto efficient improvements. Like if two people can, through their combined permissions, change the state to be a certain way, then the infrastructure should allow them to do that, right? But that requires, if you sort of approach that problem, given the computational complexity, that requires two phases: counterparty discovery and settlement. So most of the existing blockchain infrastructure is focused on settlement, and counterparty discovery generally happens off-chain. So if you use a service like OpenSea, counterparty discovery is being facilitated by access to OpenSea's order book, and in general, they're also doing the matching. And if the Ethereum blockchain is acting as a settlement layer.
So just to interject here, but like
Yeah.
the way I see this idea of statement of preference or intent and how it relates to the state of the system is that as an actor of the system, I'm participating in this global shared ledger that has a state at time X, and like at time X plus one, I would like the state to be different. So that state could be like, currently I have 1 Bitcoin and I have I have 1 Bitcoin and someone has like 10 Ether, and I would like the state to become where I have like 10 Ether and someone else has 1 Bitcoin. Is that like an easy simplification of like this idea of statement of preference and intent?
Right, absolutely. I would also add that the generality here covers cases which require a lot of coordination, which to me are often the interesting ones. So let's say that I want there to be a road, right, in my city. But I can't individually fund the road. I would be happy to fund 1/10,000th of the road if all the 9,999 other people in the city like agree on the parameters of the road and agree to fund part of it, right? And I can author an intent that will say that if those 9,999 other people agree to like such and such parameters and such funding amounts, then they can generate similar intents, and together we can settle one transaction that takes these 10,000 intents and writes, of course, the blockchain can't build the road, but writes the results of this agreement to the ledger.
Yeah, and like generally the ledger keeps track of the state, but all of these intents are typically handled, like in the case of Ethereum, they're handled in applications that are built in the state machine. Anoma, so does Anoma then sort of bring that that intent communication mechanism into the base layer system in a way that is different from like how it's currently handled in more of the application space?
Right. Sort of. I mean, there's no specific way that it's currently handled in the application space. It tends to be quite bespoke. Like separate applications have separate, completely separate pools of intents, and they have separate, generally separate liquidity. So if you, of course, if you use something like an AMM, that requires locking liquidity on chain. But even if you use something like a Wyvern in OpenSea, if you use some kind of order book-ish settlement protocol, you will need to, you have like a particular contract that you put your funds into, and then you can generate different orders, which sell your tokens for A or for B at different prices. But those orders are specific to this one contract, which seems, I'm just not convinced that you benefit from having a lot of different contracts, given that you can build a whole system that will have this liquidity pool be shared so that you don't need to, like, I don't need to know the formats necessarily of all of my counterparties' intents. I just need to know that we agree on this, like, whatever the state transition actually is. If it satisfies my preferences, then I'm fine with it. So there's like more coordination cost incurred by all of these separate protocols than seems to me to be necessary. The other major difference is that Anoma tries to decentralize this intent gossip and matchmaking, as we call it. So the process of taking intents, these statements of preferences, finding counterparties, which might number in the single digits or in the hundreds of thousands, and crafting transactions, which enact the requisite state changes, which is a hard, like NP hard search problem, and submitting those to the ledger. I think one takeaway, it's difficult, of course, to speak in such broad generalities, but one takeaway of the direction of MEV on Ethereum, which is a very helpful test case for protocol designers, because there's a lot of like a lot of real economic pressure on the system, is that there are more difficult to counter centralization pressures in the counterparty discovery phase than there are in the settlement phase, because it's easy to make the settlement phase for validators or for miners kind of fixed cost. Like you can bound the cost of operating a miner or a validator by putting gas limits on transactions and bounding the execution costs, and you can put, make people pay gas for storage, and you can bound the storage costs. But running a matchmaker, because it's an NP hard search problem, or running a searcher in Flashbots or something like this, has pretty high returns to sophistication. The more sophisticated matchmaker you build, the better you'll do. And so I think there are a lot of if we want to build a system where there isn't just one single matchmaker which takes over the world, we really need to think about the problem at the level of counterparty discovery much more than its settlement. If that makes sense.
Yeah, I mean, so one of the ways I've heard you describe Anoma is by talking about like the problems with money and everything that it abstracts away. So I think like one example is to say, like, when you buy a product, all of the externalities of buying that went into making that product, whether it's like, the supply chain and the environmental impact, or the cost of supplying the raw materials, all of that is abstracted. All that information is basically like absent of the money itself. Can you maybe like explain that that model and like how it relates to Anoma?
Right. So let me to answer one other related question that you didn't ask, but that I think might help, which is, why didn't I just explain Anoma like that in the first place? I've personally tried to start being more careful about a kind of is-ought distinction. As technology is a tool, I think, say, dealing with economic complexity is a reason why you might want to use a protocol like Anoma. And I, personally will make the case for like why that might be something worth considering. At the same time, I think it's already so difficult because these stacks of cryptography and distributed systems and blockchains are quite complex and intricate and still understood by a pretty small fraction of the world. It's a really difficult challenge to articulate the features which that technology doesn't provide in a way that is accurate and safe. And if people are going to use blockchains to do important things like operate their economic systems, it really needs to be accurate, like the understanding of the technology which we convey to people. So, for example, often I hear things about like blockchains are trustless, which I think is just this, if for specific definitions of that word, it's true. For specific definitions, it's false. But to the broader populace at large, I think it conveys just this, like, it's too much marketing, and it is going to backfire. So I'm trying to be really careful about that. That aside, so why would you want, like, one question you might ask is, why build this whole super complicated distributed system with cryptography and all this like fancy math, and why like try and organize people for years to build these things? What purpose does this have? We already have money. Can't we just use it better? One reason for me why you might be interested in this is simply that the economic economic system as it currently stands is not adequately handling complex impacts. So if you think of the economic, what does the economic system as a whole do? You know, in some ways, probably it's asymmetric, right? It like enables, say, as it like stands in the world, enables certain parties to exploit other parties or something like that. But at least, you know, in theory, what something like money does, if the playing ground is even, is just allow for coordination on the basis of information transmitted up and down the supply chain with prices. So if a lot of people are buying a specific kind of coffee, then a producer knows that they should produce more of that coffee, right? Like nothing seems super awry in this scenario. The problem is that when supply chains get really complex, information gets lost, which people actually care about. So if there are a bunch of companies competing to produce a particular good, let's say coffee, and they can sacrifice certain values, such as you know, environmental impact, like let's say that they can produce coffee in a way that reuses the same acreage, the same farmland, repeatedly year after year with the same crop, which tends to strip the land of nutrients as compared to rotating crops or rotating land, but sometimes is like cheaper. It's just infrastructurally cheaper because you don't have to move stuff and you can build automation in place easier. So if they do that, the coffee which they produce will taste just as good, at least for a while, and it will have a lower price, right? So if consumers are making decisions on the basis of price, they will pick the cheaper coffee. However, over the long run, this will result in like you know, land which is no longer arable, and this wherever there's this kind of trade-off between being able to produce cheaper goods and some other value, such as environmental sustainability or carbon emissions or labor relations, which the people buying the coffee probably do care about, but just don't know about, then in using only price as the metrics of selection, all of us who are buying coffee are kind of unintentionally creating this incentive for all of these coffee producers to you know, strip the land of nutrients and emit more carbon or do whatever it will take to produce cheaper coffee. So why don't we, you might ask, why don't we just like unionize and say like, we're never going to buy coffee unless you follow such and such practices? That would be great. Unfortunately, most of us have other things to do with our lives rather than just like unionize on behalf of everyone buying coffee. Buying coffee is a pretty small part, at least in my life. Still do it too much, but it's still a small part. And you know, if there was some way for me to easily find other people who are buying coffee and kind of create a sort of consumer union to negotiate as a group and get suppliers to incorporate more factors, such as the environmental impact, into their production choices, then that I would be thrilled to do that. But it kind of needs to be easy. So I can't go spend my life right now unionizing people buying coffee, and that seems difficult to do considering that there are, I don't know, billions of them and they're very spread out, right? But if we can track these economic transactions and see the impacts they're having along the supply chain and track, say, what kinds of environmental impacts companies have with certain production practices, then using the ability of, you know, a sort of a distributed system like this, plus money and digital signatures to make credible commitments, we can commit not to buying coffee unless producers follow certain practices. And as soon as a lot of people do this, say on the downstream end of a supply chain, the incentives for producers change. So if as a producer, I can no longer sell any products if I don't adhere to certain environmental production practices, then like I'd better change what I'm producing and how I'm producing it, or I'll be selected out by just the normal sort of economic selection process. So I think blockchains only solve part of this problem. They only solve the like computational part, and still the hard Oracle problem of actually checking what companies are doing remains. But solving the computational part is helpful. So I think it's worth trying.
And how does Anoma solve that computational problem?
Mostly by crafting this system where people can express their preferences by intents and by architecting the way in which data is verified in the ledger in the way, I mean, it's important for companies that their production practices or what specifically they're doing can mostly remain private, but it's important for consumers who have preferences about the environment, shall we say, that they can check that companies are adhering to certain practices. So Anoma provides this like large-scale intent gossip matchmaking and settlement system to allow people to credibly express preferences. And to, I mean, this requires that you like commit not to buying coffee, right?
Mm.
And it could be contingent on other people doing the same thing, but you
Yeah.
have to make a credible commitment to up the supply chain that will transmit information. And this is information that you just can't transmit with money as a tool, because the only thing you can do is like not buy the coffee. But that doesn't convey that you would buy like another kind of coffee if it were produced more sustainably, and it doesn't convey that all of these people together have this preference, right? So there's kind of there's a need for a more high-dimensional mechanism here.
How does that manifest, practically speaking, like when using? So like I think maybe it's helpful to talk about like the infrastructure stack. And so you have Anoma, and then you guys are building different I guess products or blockchains on top of Anoma. How does, like, for instance, what you're talking about here, how does that manifest in the stack? Is it would this money, like information rich money, be built on Anoma, or would it be an application that is sort of like higher up in the stack?
Right. Our answer to this question has changed over time. Initially, we set out mostly just to solve this like economic preference and more high-dimensional bartering problem. But in the process of doing that, for example, in the process of coming up with a private bartering circuit, we ended up with Zexy. And so we've sort of realized that these components of architecture and application are in a certain sense orthogonal. And so it makes sense to consider bartering and this kind of intent crafting in for specific purposes, such as for purchasing coffee or communicating preferences about sustainable production. It makes sense to treat these as an application on top of the Anoma architecture. But the Anoma architecture is a bit right. So should I say what that might look like as an application, or?
Yeah, sure.
Okay. So as an application, then you would use a language called Juvix, which is the way in Anoma that we write intensive validity predicates. You would use Juvix to write specific validity predicates and intents to describe the act of purchasing coffee and to describe the different production practices that producers are employing, and to describe the oracles they're using to verify those, and to describe the kind of settlement system whereby, for example, a bunch of let's say that there are like 10,000 people buying this kind of coffee. And let's say that I, as one of those 10,000, want to negotiate with the producers to produce something more sustainably. But I only want to do so if I kind of only want to do so if my negotiation would actually work. Like if I'm individually changing whether or not I buy coffee, this won't actually change the producer's incentives, right? So what I do is I craft an intent that says that I will not buy this kind of coffee if 5,000 other people, so half this group, also agree not to buy this kind of coffee. And until 5,000 people agree, nothing happens. I mean, I just like create this intent, I broadcast it around, but people can see that were they to agree with me, then we would, and were more people to agree, then we could.
You're essentially like establishing a demand.
Right.
For
You're
the
establishing a
product.
sort of counterfactual demand.
Yeah.
And you're establishing it in a way that is legible to other people who might have similar preferences. And they can see that you would like this state of the world. And they can, if they agree with you, sort of credibly state in the form of an intent, including digital signatures, and potentially cryptographic proofs, that they agree with you, and in a way that will bind them if enough people agree. And then that can be settled on the ledger once you hit 5,000, and then that will communicate. I mean, maybe producers can even see this like before it happens, right? But at the very least, at that point, it will communicate to producers that their incentives have changed.
So in this example, I mean, I could see a situation where you would have perhaps opportunities for Sybil attacks here, where one or several parties could be signing for each of those 5,000 participants, like, to reach that threshold. Does Anoma have the Sybil resistance mechanisms to prevent that, or is that something that one would have to build in their own application through like KYC or some other form of mechanism?
Right. So I think in this particular example, you actually don't need a really strict or like really unified notion of identity. I think you only need the fractional identity of people buying coffee. And the blockchain does know about that because
Mm.
in order to, of course, realize this, you have to be buying the coffee in some way that could be like verified on Anoma, right? But presumably you're, sending some funds privately using the shielded pool in order to buy your coffee, and you can create a proof of that, and that's sufficient. Like we don't need a stronger notion of identity because the producer just cares about the people buying the coffee, and the people buying the coffee just care about, like, in addition to buying coffee, they don't want to wreck the environment by accident. And that's really, I think that's all you need. So that the purchase itself is the civil resistance mechanism in this case.
Okay, got it. Yeah. Okay. Yeah, I see what you're saying. Cool. And so we didn't mention. I don't think we really talked about this, but that Anoma has privacy by design. Can you explain how that works and how it? Because I think typically one of the things that private preserved blockchains enable is obviously like having private transactions, but it does create complexities in terms of creating useful applications. How does Anoma sit in this maybe spectrum?
Right. Anoma sits at the point that basically we should provide privacy, privacy where people want it. Sometimes you don't want privacy, but we should make it an explicit choice, and we should, you know, give users of the system, potentially through intermediaries like interfaces, the tools which they need to craft like exact statements of what kind of privacy they're getting.
Yeah.
So also, I guess from the architectural perspective, we're really trying to figure out like where are the information theoretic bounds on what kind of privacy you even can have, and like what are the cryptographic components to instantiate that in different ways, and can we arrange this in an architecture that makes sense where we can just slot in different cryptographic components later on as they get improved. So for example, in order to discover counterparties, you have to share information. Like if you don't, in some very crazy extreme universe with infinite time, you can fully homomorphically encrypt everything, and you just like test two intents to see if they match. But then you have to do, n factorial tests in fully homomorphic encryption on the number of intents, and it's never going to work, right? So in order to discover counterparties before private settlement is sort of a programming architecture challenge, but information theoretically is fine. But in order to discover counterparties, like if I have 10 Bitcoin and want 1 Ethereum, and you have 10 Ethereum and want 1 Bitcoin, we don't need to reveal who we are, but we need to reveal what we want. So in the Anoma architecture at the moment, users, when they craft intents, can do not reveal their identity, but they do reveal what they want, the preferences that they would like to be enacted. And they need to reveal that to enough other intent gossip nodes to discover counterparties. Once they've discovered counterparties, that can be zipped up, or so to speak, with a zero knowledge proof, and then submitted to the ledger for settlement.
So what kind of applications are you or others building on Anoma? So we've talked about, I think, some examples that are somewhat hypothetical. I think the whole like coffee example. I don't know what would be required for that to actually manifest. But like, what are the practical things that are being built?
So I should caveat all of this discussion with we've decided to launch Anoma, as it's architecturally quite a complex project, in several stages, which have successively more complete versions of the protocol. So the first stage will be a blockchain called Namada, hopefully launched this summer. Of course, Namada, right?
Yeah.
We can only propose Genesis blocks. It's up to the community to decide what they want to run. But Namada will feature private transfers, IBC, proof of stake, cubic slashing, a bidirectional Ethereum bridge, and some other cool things, but it will not feature counterparty discovery. Counterparty discovery we are incorporating into version 2 of the Anoma protocol, which hopefully will be ready later this year or soon thereafter. So the first application for Namada will just be multi-asset shielded transfers, which seems kind of banal, but it doesn't exist yet. and I would like, at least personally, it's like something that I would use. I would much rather pay with a zero knowledge proof on my phone for all of my everyday transactions rather than using a credit card, and also rather than, I mean, to um, give credit where credit is due. Zcash is an amazing project. They have basically single-handedly kickstarted the integration of zero knowledge proofs and privacy technology into blockchains. At the same time, I'm not convinced that the economic model of Bitcoin as an asset makes sense for payments. Like when I want to pay people, I don't want to use the asset as a store of value. I want the asset to be stable with respect to the goods that I'm buying and selling. So I would be fine, honestly. Like if the European Central Bank could just issue euro and allow, and we can change the back-end settlement infrastructure to be, the multi-asset shielded pool or sort of sapling style private transactions, that would be a huge improvement over the current financial system with
Don't
terms
stay
of
up waiting for
privacy.
that though.
Right. True, but at least we can, approximate more stable assets in different ways.
So when you say multi-asset shielded pool, you're talking about IBC assets being
Right.
transferable on. Okay, so with this product, one would be able to move any IBC asset into these shielded pools and transfer with privacy preserving transactions.
That's right. And the way the multi-asset shielded pool works, the privacy set is additive. So all of these assets share the same privacy set. No observer of the
Right.
chain can see which asset you were spending.
So is it similar to Tornado Cash from the like privacy pool perspective?
Um, Tornado Cash does not use sapling, at least not as far as I know. In the first version, they had quantized amounts, like specific. I think they've changed that. So now you can do variable.
Yeah.
So in that sense, the privacy is it's probably pretty similar. Um, I don't know if they leak any more information to the sequencer or not.
Remind me what's sapling again? I feel like I know this,
Sapling
but I
is
forgot.
the circuit architecture that started with the Zero Cache paper and was incorporated into Zcash, as then the first circuit was called Sprout. The next circuit was called Sapling. The most sort of recent circuit proposal is called Orchard. And the
Okay.
multi-asset shielded pool, which Namada will launch with, is based on sapling, but adds support for multiple assets. So similarly, like Zexi as an architecture is sort of a descendant of the sapling architectural lineage of circuit design. And the
Okay.
reason why there aren't more circuit designs is that the way you get privacy with zero knowledge proofs is to have the user who's transacting with the system hold the data themselves, so that like you can think of it as like a sharded database where the data is at all the edge devices, and that's what provides privacy. It's just like the data is on the device, and then the user has to make the proof. So that sort of informational topology pretty much necessitates that you shard the state like this, and that pretty much necessitates something that looks like UTXOs, ergo sapling. So I don't know exactly what the most recent version of Tornado Cache uses, but if it supports full privacy for asset denomination, asset amount, and sender and receiver, it probably has a node tree, which means it's probably like sapling, although maybe not exactly.
Yeah, I'm not sure exactly. I mean, we interviewed them on Epicenter quite a while back, and at that point, you couldn't do variable amounts. I think that's been introduced now, but I'm not quite sure how that works. Maybe there's some zero knowledge proof stuff going on there. So I wonder. So this is something that just came up here. Is a good way to think about this the following. So if we look at the this whole new like modular blockchain space where you have data availability layers and execution layers that provide proofs to those subsequent layers. So, Celestia is one example. We had Redstone on last week. They're doing something similar with Arweave. I think ETH2 is also moving in this direction. Does it make sense to think of Anoma as a kind of data availability layer, but with privacy? Or is that analogy like totally off?
Interesting question. I think
It feels to me like there's some kind of like modular aspect here where
right, right,
there's a
right.
base
So
layer that provides some primitives and then applications that can leverage that layer.
right. I should caveat this with I am, I've talked to people at various projects doing different parts of the modular blockchain stack, but I'm not an expert in all of them. So my, summaries of kind of the differences in philosophies here could be somewhat misleading, and I would love to like bring someone who is an expert on that particular approach to chat with. To me, I think the way I would contrast the approaches is that where they place the heterogeneous security. So an approach like Celestia or ETH2 is vertically heterogeneous. Like the data availability layer has one security model, say the ETH2 validators, and the execution layer or sequencing layer has another security model, say different roll-up sequencers.
Mm,
And the even sometimes the dApps on top have like their own DAO or something. They have their own security models. Um, that's advantageous from a development perspective, and that different sort of companies and organizations can build these different parts. Um, One disadvantage it has is that in general, the security you have is like the weakest of all of those layers.
yeah.
So if you're using, if the DAO associated with the dApp can, by majority vote do something, or if the data availability layer gets corrupted or something like that, then it doesn't matter if the other layers are secure, right? And
Yeah.
it's also tricky to, I think that's a tricky model to explain to people using the system, because the entities or actors they have to trust are involved in operating all of these like intermediate architectural components, as opposed to operating like some unified thing. But the other usually like Celestia or Ethereum, um, I don't know how much they take this as philosophy, but um, are seem to be operating under the idea that there can be like one single data availability layer, and there are advantages to doing that. It makes like cross-domain MEV, well, I don't know if it makes that simpler, but it makes like you have this like very large security set, and it's sort of hard to corrupt the system because there's just one and it's very big. But on the other hand, there's like a singular mechanism, and if the whole world uses ETH2 or Celestia or whatever, it doesn't matter. But if the whole world uses one data availability layer, then that's just the most massive honeypot in existence, right?
Yeah.
So what I
I think
would
this idea that I'm like I still understand people who believe that there will be one data availability layer or one blockchain or one. I mean, like, um, yeah, it's hard for me to wrap my head around this becoming a reality. Um, just because of just because of the way humans coordinate, and just the same way we don't have a global currency or like one global government. Although that might, who knows, maybe that'll become the case one day. But um, I think that things typically, if you look at just like something like the Linux kernel and all of the different versions of Linux that has produced, and um, operating systems, and different like web technologies or development, like just programming languages and things like that. There are going to be use cases that are going to be more. Some technologies are going to be more suited for some specific use cases, and it
Mhm,
might
mhm.
be that we end up with like, you know, an oligarchy of data availability layers or blockchains where there are like three or four that capture most of the value, but I can't wrap my head around there being one, that
Right. I
captures
mean,
95% of the value.
yeah, I mean, different people have different design philosophies. One, for me, one thing that's important is crafting a system that is like resilient to faults, and especially crafting a system where local guarantees are not dependent on globally trusted actors. So, for example, if we just think about the topology of actual commerce, right? Right now, say, economic settlement of transactions in Berlin is dependent on a credit card network operated by Visa, like probably in some data center in, like, I don't know, Norway, which means that if there's a sort of loss of geopolitical complexity and some of these structures no longer cooperate perfectly, then we can no longer do commerce in Berlin. Not only can we no longer do commerce between Berlin and Norway, right? That makes sense. But we can no longer do commerce here because we're dependent on this system, which is controlled by somebody far away. So for that reason, I think it's like, that's a reason you might want to craft security models where you keep the zone of trust as local as possible to the community which you care about. And often the community which you care about is physical, but it's not always physical. It might be like a particular game that you're playing, or particular like network of people who want to, engage in some kind of, say, economic relationships together. You don't want to extend trust to people or entities outside that network where you don't have to. And for commerce, which is happening within that network, you don't have to. So run your own blockchain. Like, don't use somebody else's data availability layer or settlement layer or rollup layer or whatever. I mean, just like you don't, run your own local area network for your LAN party. Right now, this is hard, but that's a technology problem. It's not like a sort of topology problem.
Yeah. So let's maybe talk a little bit about. I wonder what your vision is for blockchain infrastructure. So in the last 10 years, we've had, I think, several iterations of the technology stack. So we started with Bitcoin, where like everything was built into one one binary basically, and then Ethereum created like an extra layer where you have applications that can now run on that on the virtual machine on this binary, and then Cosmos created and by some extent also Polkadot and some other modular blockchain systems extended that horizontally, where every chain has its own security model and has its own application. And now we're starting to see fracturing, I think, with the modular blockchain, like more modular blockchain infrastructure design patterns like Celestia. And caveat, like, I'm also not very like super familiar on how that works, and I want to dive into this on a podcast here with people from Celestia. But where do you think, like, what do you think this is going to look like in 5 years from now? And maybe, I don't know, like, I don't know if looking back at how Web 2 infrastructure has abstracted makes sense. Is that a good reference point? Because like Web 2 has gone through similar phases as well, where we started where you had very centralized infrastructure where everything was running on one system, and now things are very much abstracted, where you have like functions basically running as a sort of like as a VM, and like databases being decentralized. I'm also like not an expert on Web 2 infrastructure, but I can see the trajectory there, and I wonder if it makes sense to look at that as a model for how things could break apart in the sense of like modularizing in the blockchain infrastructure.
Right. I think it's important to me, at least, to differentiate on two dimensions of modularization, which I think are kind of orthogonal, or like will end up being orthogonal. There's technological modularization, which just makes sense. I mean, you can come up with, if you want to, in order to architect complex systems, you need to split them into smaller parts that you can reason about more easily, and you need to have clear abstraction boundaries between these parts. That always happens. It happens like with layers in the internet protocol. It happens with abstractions for running functions in Web 2. It happens with sort of modular blockchain infrastructure for Web 3. Right? That will happen. But security, I think, is a sort of orthogonal dimension where you do not want complex security. You want simple security, and you want to often like, you need incentive alignment, which is not financial. I'm skeptical of like purely financial incentive alignment model. For example, proof of stake is a purely financial incentive alignment model. And most of the, like, if you have a large like modular blockchain stack, most of the layers are operating on purely financial incentive alignment models, where you assume that the like operators of these different layers in the modular stack aren't like, they don't care about the applications, they just care about their particular reward function for operating their layer correctly. And that has advantages. I mean, it's like kind of easy to reason about that in isolation, but as long as they have some selective choices to make, like which transactions to include, for example, or which like applications to support, or which rollups to prefer or something, then their decisions on, that are always going to be like just financial, kind of disconnected from what the system is actually being used for. And I think that, it's not clear that it's difficult to make these systems actually decentralized or decentralized in the long term, because there's no identity. It's just proof of stake or something like this. So I think in order to get, in order to facilitate long-term incentive alignment, we should consider models where we expect that the, say, validators or the parties actually operating the infrastructure are really like part of the communities which it is serving. And really, we should like move in the direction of eliminating this class distinction between validators and delegators. We want there to be, we already have we have devices that can or will soon be able to run all of the infrastructure, right? They're here. I mean, it will take a long time to, it's cheaper to have centralized compute, right? There are gains to sophistication, but centralized compute is just compute controlled by somebody else. So I think security will move in the opposite direction of going towards like as vertically integrated and towards the edge of people who are actually using the systems. But it will do so in like spurts, because some centralized system or originally decentralized and then centralized by trajectory system will fail, and then users will realize that they should really control the infrastructure themselves, and then they will take the sort of cheapest exit option for their applications.
And what do you think is like the practical path for the Cosmos stack to align with this vision? Like, how does the Cosmos stack modularize, where currently, nodes run consensus and the application layer, with it through ABCI and Tendermint? Do you think that these two pieces will at some point modularize, where some actors will run security for a bunch of different applications, so like cross application, and then applications will leverage that security? And maybe this fits into the whole interchain security model that the Cosmos Hub is implementing. But it feels to me like the Celestia model is like even more evolved than that. I haven't quite like made up my mind about that yet.
How do I think the Cosmos stack will evolve with it? Well, I mean, I think one question that is really important to consider, because it has a very different answer than like the immediate short-term economics, is what will drive standardization. Like what will actually drive specific parts of blockchain architecture to be or not be a certain way. And currently, like the thing driving standardization is protocol funding. And protocol funding, like the fact that the protocols are the ones getting funded, incentivizes divergence and experimentation. So there are a lot of different architectures, and there are a lot of architectures which are similar but slightly different in certain ways, and they're operating independently. That's cool. I mean, it's like very different than Web 2 was. I think it allows for a lot of architectural experimentation, and architectural experimentation is helpful. Like different architectures have different security models, but it's not clear to me that it will drive architectural economics in the long term, because users don't care about architectures. Users care about applications. And we see this, like you already kind of see this with a bunch of chains wanting to support the EVM. I mean, the EVM is an odd choice for a standardized virtual machine for blockchains. Let's just put it that way. But still, there's like people want existing dApps to port themselves, and dApps do. Like you see Uniswap on like lots of different chains, right? And users know Uniswap, and they know they're sort of used to this, like they're used to what it does, and they're used to the brand name. Right now, this is a huge, like I think it's a security disaster waiting to happen, because it's not Uniswap that has a security model, it's the blockchains which have security models. But users, there's this like complete disconnect between what people see as like the thing that they're interacting with Uniswap and what the security they're actually getting is, which is very, very different on different blockchains. And currently, this is sort of whitelisted by like Uniswap having a reputation and deciding to support different blockchains or something like this. But I think that's probably like going to fall apart eventually. Not in the specific case only, just in general, because it depends on this trusted intermediary having reputation and making good decisions about which blockchain to support. And the like if users treat all those blockchains as equivalent, then the security is like the security of the least secure one, right? So I think from that perspective, what is very important for sort of anyone aligned with the Cosmos vision of heterogeneous security is to reduce exit costs for applications, and to allow for abstractions which can make it more transparent to users what security they're getting. So right now, if you use there aren't that many like super multi-chain dApps, but there's some that are starting to be. If you use a decentralized application, which is going to sequence state transitions on a bunch of different chains, this can be with bridges or it can be with IBC, but over some kind of cross-chain infrastructure. Then, right now, most of these applications do not have strong fault isolation properties. They're just like they whitelist some chains and they have their state sharded, and if any of the state on any of the chains gets corrupted, their whole application security invariants are lost. But the way IBC approaches things does isolate security on different chains because the chains are the atomic units of trust, right? So then, like, say, users who don't send a particular token, and a token is an application, right? So users who don't send their atom to another chain are never subject to, inflation potentially from security faults on that chain. I think it's very important to generalize this, which is harder, but it's possible. And then that will allow developers to write applications on top of the stack that allow users to use the same application, like the same kind of conceptual model for doing something like swapping with an AMM, while choosing their trust zones.
So you don't think that that security will become? You don't think that like the block production will become a commodity? You think that there will be clear distinctions between security models that users will have to make choices upon, like which security model they choose to transact? Because I've heard people talk about, I've heard people say that like block space will become commoditized in the sense that like the trust layer of blockchain networks, because of the I don't know how really to explain this. I kind of like,
you mean like they'll become fungible, like you just will post your
yeah. I think that's what it gets at, is that block space will just become this sort of fungible commodity because we need to have as much block space as possible. I think the assumption is in order to remain decentralized, we'll need many different security models producing blocks and validating state. And
I'm skeptical of this because I think there are things that it's just very hard to incentivize. The one thing that is very hard to incentivize is storing data for a long time. So for example, in a model
tell that
like
to the Arweave folks.
Right, but I mean, in a model like, in a model like Arweave, I'll start with Arweave. Arweave is a cool project. No hard feelings.
Yeah,
but I
think the economics are still like to be.
Yeah, I mean, in Arweave, there's no coordination between people who store data. So there's, in the absence of some separate system for coordination, there's it's like kind of inefficient, and there's no way for a user to check that their data is actually stored. Like there's just, other than requesting it, but there's no way to check that it will be stored or check that, like, you have to trust. And trust is fine, but if your trust is very abstracted away from you in this like large network of commoditized, whatever, Arweave block stores or Celestia block stores, then it's abstracted very far away from you, and it's like harder to, you can't like talk to them, and they aren't necessarily part of your community, and they don't have any kind of long-term incentive alignment with the actual like economic system that people care about that you're using all of the settlement infrastructure to support. So I think that that is one reason you might expect certain things not to be commoditized. I think some things can be commoditized, like maybe making zero knowledge proofs can be commoditized because it's really just computation, and you can like make it so that the doing the computation doesn't like you don't learn any information, you can't censor anything, you're just doing the computation. Probably that can become commoditized. But anything where there are, sort of long-term incentive alignment questions that you just can't craft a protocol to like somehow verify, and data availability, I think, is one of those. I don't think like there might be waves that might become commoditized because we built some of these projects, and then it'll take 5 years, and then it'll break, and then we'll realize it like isn't really commoditized, and then it'll be uncommoditized. It'll take a long time.
Yeah. And we haven't really talked about IBC yet, and I'm conscious of your time here, but I wonder if we could just maybe spend a bit of time here, and then we'll have to do a whole other episode about heterogeneous consensus, because I think like this is also pretty fascinating. So yeah, I mean, with I like I think we all agree that interoperability of blockchain systems is fundamental to the success of these technologies. But one of the things I see IBC and interoperability creating as a problem is like non-fungibility of assets.
Mhm.
And we're starting to see that now. Like, I mean, this has already been the case, I think, in Ethereum for some time, but we're starting to see it now, with like Evmos and different bridges coming on coming on board in Cosmos, and it will become even more complex when you have bridges now cross ecosystems. So like tokens moving from the EVM world over to
Mhm.
the Cosmos world. How do we solve this? Like, what's the solution here? Because I mean, as for users, it is incredibly complex, I think, to try to reason about what tokens represent what, and what the security guarantees are. And yeah, I don't know, like if people are actually thinking about this problem and trying to solve it with like actual solutions, but it seems like a big one.
Right. I mean, so IBC is built very like conservatively from a security model perspective, which I think is what provides the kind of safety and default isolation, that in the long term at least you want. Um, but of course, there are some UX trade-offs to that, and one of them is that when you send tokens around in all these different directions, they are non-fungible with each other because they went through different security paths. Um, in the sort of like at least in the like IBC model of chains which can talk to each other, um, these security paths can be so there are different levels. There are different there are different levels of the stack at which you can try and improve this problem. One level is kind of like what we'll just call it the sort of top level, is you can try and make markets. So there can be some arbitrageurs, and they'll like trade your Gravity USD for your Axelar USD or whatever, and you pay some like slight fee, and they assume some risk. That's not the worst solution in the world in some ways, but it does require this like separate class of people to perform the service, and it means that users are incurring some costs, and it means that like there's still state transitions going around to actually send the tokens, right? So you can, in the case of IBC, we have what's called the diamond problem, right? And in the case of bridges writ large, which is that if we have some tokens on chain A, and we send them to chain B, and we send them all the way to chain D, and now we want to send them back. So one thing, like it seems like, let's say all these chains are functioning fine and dandy. One thing it seems like we could do is we could send them back through C all the way back to A. But the problem with allowing this is that if you send the tokens back to C, then like you could also, if at the same time you still, from chain A's perspective, chain B is the one who has the tokens, right? So if you allow these tokens which came from chain B to go to chain C, to chain D and back, then to chain D, then chain C and back, then chain B could also send back the tokens at the same time, right? So in order to prevent this, these chains need to agree on who holds the tokens. So if chain A, chain B, and chain D can agree that like these tokens have now been transferred to chain A from chain A to chain B, then chain B to chain D, then chain A can allow them to be sent directly back to chain A, because chain A has now changed its ledger to say that, like, originally I sent 50 tokens to B, but now these 50 tokens are owned by D, right? So in order to do this, you need to do a consensus between the blockchains. So you need to do like a two-phase commit or something like this, but you can batch all of this together and like reduce chains of provenance for many different applications such as tokens at once. But it requires that your consensus layer like understands this stuff. So it requires like a re-architecting at the layer of Tendermint, I think. And it doesn't, I mean, you still have, these are still separate zones of trust. So there's still like tokens on B and tokens on D are not the same thing. But if you can get if you inform A about the balance changes in a way that A can verify is actually coming from B, and it can change its ledger to reassign things to D, then that will allow you to, like, now they're still like A tokens and they're only one hop away, or so to speak.
Okay. And so what kind of architecture changes to Tendermint? Is this the work that you're doing with heterogeneous Paxos and Tendermint 2.0, or is that something else?
In part, I mean, you can build two-phase commit on top of existing systems. Like, you could build it on top of Tendermint without rewriting Tendermint. It's just a bit less efficient. What really needs to be integrated is Tendermint and IBC, because if the consensus layer is aware of this interoperability, Gossip becomes more efficient. We can like bundle all of these. It needs to be aware of the other validator sets, so we can kind of automatically reduce these chains of trust provenance in cross-chain, cross-security zone applications. And in specifically our case, the other thing we're working on is trying to enable atomic cross-chain transactions, or at least synchrony bounded ones, for which you require some overlap in validator sets or some specific additional assumptions.
Okay.
And in order to get either bounded synchrony, because IBC treats Tendermint as a black box, right? Like, Tendermint just produces some blocks or it doesn't. And there's no visibility into the validator set, right? So in order to do synchronous or atomic cross-chain transactions, you need to check that there's sufficient validator set overlap. And you need to schedule between those two validator sets a joint commit around, or you need to enforce synchrony bounds in your block acceptance criteria. And all of these require awareness in between the sort of interoperability and consensus layers.
So what are you most excited about when it comes to like the future of IBC and some of the things that are coming there, like interchain accounts and stuff like that?
I'm most excited about IBC becoming boring. If IBC is in 10 years, like, is the internet protocol really exciting anymore? I mean, people are doing cool things with it, but no. It's there, it works. You don't even need to think about it. People who do not understand it can buy hardware and like use it pretty safely by plugging in cables. I hope that at some point IBC looks like that. Admittedly, that's a long way off. In the short term, I'm really excited about people using IBC for anything other than token transfers, because I'm just so bored of token transfers.
Like what?
So interchain accounts are cool. Interchain accounts introduce complicated security dependencies. I think that's something that is difficult to communicate. If you add more blockchains into your trust model, your security is, unless you were doing other checks, as secure as the weakest one. It is convenient in some ways, but I hope that will be sort of clearly elucidated. But it's a cool feature. I'm excited about. I mean, there are all these like interesting features we had planned for IBC protocol development, and they got cut from the version 1 release. But I don't know if anyone needs them yet. But they would be cool, such as like partial ordered packets and sort of broadcast 1-to-N broadcast channels.
Oh yeah, that'd be cool.
Yeah, I'm also very excited about ways like higher level abstractions on top of, IBC is a really low level programming primitive when you think about it from the developer's perspective. It's like if you were writing a concurrent program by specifying exactly all of the messages the CPU cores had to send to one another. And that's not something people do anymore, because there are better tools that will like use the mathematical properties of the computation you're doing. For example, you're doing MapReduce, or you're doing some kind of accumulation over a monoid, something like this. You're doing addition, multiplication, these kinds of computations just by virtue of their mathematical nature can be parallelized, right? And similarly, we can come up, it has to incorporate the additional dimension of trust, right? But we can come up with programming paradigms over concurrently executing blockchains that are much easier for developers to write applications with, and ultimately like compile down to messages being sent between the blockchains, just as whatever you fancy stuff you do in parallel Haskell compiles down to messages being sent between CPU cores or being stored in shared memory or something like this. But developers don't need to deal with this kind of lower level of abstraction and can reason more easily about the safety of their applications by exporting some of the correctness checks to the compiler.
Okay. Yeah. And are you still like actively contributing to IBC, or has that moved on to someone else?
I still I still review PRs sometimes, and definitely not all credit to the IBC team at IG is doing all of the actual work. I just occasionally like say silly things like, I'm worried about something, please write more about this in the specs, and sometimes people do, which is wonderful. One other thing I'm excited about, or I think is kind of a design imperative, is private cross-chain transfers. If we have like many different privacy sets and they're all split across different blockchains, and every time you bridge, you do so in public, that's just going to create a lot of linkability. And we're splitting all these privacy sets, and then blockchains are like competing with each other to have bigger privacy sets, which is completely unnecessary. Because if we have private bridges, then even if we can keep the heterogeneous security domains, right? But then we can have one privacy set. And then we no longer, like, blockchains don't need to compete on having a bigger privacy set than other blockchains. They can just share a single privacy set, and users can choose their security domains independently while getting like the privacy of everyone. Not perfectly, but pretty close. So we are working on a proposal for a private IBC bridge, at first for like measurable assets, fungible and non-fungible tokens, and maybe later on we can generalizing privacy and trust at the same time is two dimensions of difficulty, but in principle possible.
Yeah, that'd be pretty cool. And I have a final question for you here, because this came, and I know this is like, it's not super relevant anymore since it's no longer being voted on. I don't think so. Oh, no, actually, it is. Yeah, it is still in voting period. CosmWasm on the hub. What's your view on there?
Yeah, I should caveat this.
Did you vote? Did you vote?
No, I didn't vote. I think that people should be governance stakeholders when they are really like aware of the processes going on and different trade-offs and different considerations, and I am not. So I don't want to like claim some kind of knowledge that I don't have. In my view, blockchains are basically useless. They like currently serve to they currently service like some pretty simple financial applications that by some lucky accidents of funding models have allowed us to do a lot of work on blockchains, which is nice. But I think that the kind of we really haven't seen a wide variety of applications proliferate yet. But at the same time, this like extensive amount of financial usage has led to a sort of early solidification, because all of these systems are like, oh, it's like transacting hundreds of millions of dollars. Like we have to be super conservative about not changing it. And I think that's kind of tragic, because it means that we're not iterating anymore, because we're terrified of like breaking this financial system. So number one, I would say stop using public blockchains as financial systems. That's a surveillance capitalist, like authoritarian dream. It's awful. Public blockchains are awful. Like all of your financial information is going to be public for the rest of time. And it's only a matter of, Chainalysis is already selling like, along with Coinbase, your identity data to whoever is involved in your government, if you're lucky, and also a bunch of other random companies if you're unlucky. All of that, what's the relevance of that to CosmWasm? I guess only that I think blockchain should be just much less conservative. And people should not treat them as, battle-hardened financial infrastructure, because for other reasons, they're not qualified to be it anyways.
Yeah, I mean that's hard though when you look at big numbers on your screen.
Yeah, but I mean, if we're
Yeah.
still if we're comparing things in terms of US dollars, then like, have we really built an alternative financial system? I don't think so. It's not the right metric.
No, no, I agree, but I think at the individual level, people tend to be conservative when their relative wealth increases, and I mean,
Right,
like
right, right.
you can see this in all sorts of like wealth acquisition. So I think there are other
Which
studies
is
that point to buying real estate makes you more conservative, and I think that from that perspective, like people who have gotten relatively more rich in the last like 2 to 5 years or even longer. And this is the case like with Bitcoin, right? Like, I mean, like
right.
Bitcoin is super conservative because the people who have been building and involved in Bitcoin since 5-10 years from now have gotten like immensely rich. So it's like a human nature problem. It's more anthropological, I think, than it is than anything else.
Right. I mean, at the same time, I think there's absolutely a case for having different blockchains or different sort of components of this large distributed system, which take different trade-off points along the like
Yeah,
spectrum of being innovative to conservative. And I think maybe like one challenge the Cosmos Hub has is that it doesn't have a really clear thesis as to where in that trade-off space it should lie. Like
yeah,
Bitcoin has a really clear thesis, and the community around Bitcoin has, I mean, if people didn't like that thesis, they went and did something else, which I think is good actually. But the challenge of the Cosmos Hub, in part because it does have a governance model, so it's like possible to change it, right? Is that there's not really I think different founders of the project have different perspectives, different users have different perspectives. The hub team at IG is like doing their darndest to make the hub useful, an approach which they should be lauded for. I mean, it's like very completely plausible. Cosmos Hub just becomes useless if it doesn't do anything that people actually want in the long term. Um, so I think it's difficult to. I mean, here's my crazy proposal, which no one will ever implement because I'm not not an official stakeholder. I could say this, right? I think the hub should like fork the token. So there are other ways of like one thing I think one thing people do is like an airdrop to certain stakers who voted a certain way, which is an interesting option. But I think it's not as clear a like split. So I think you can sort of split the like history of the Cosmos Hub, and people, if you want, people can. And you have to construct a proposal which actually does this, as opposed to this proposal which doesn't. Right? Like the preconditions should be clear, but you could construct a proposal where people can vote. Like, would they like to be the part of the Cosmos Hub, which will take the approach of being very stable, and be the part of the Cosmos Hub, which will take the approach of being very innovative. And then you actually split the asset. So as opposed to like forking and copying the asset, you split the asset. So there's like Atom 1 and Atom 2.
yeah,
And, the market can value them differently, and people can like exit into one or the other if they want. And that to me would achieve the kind of like, could achieve the kind of clear bifurcation of philosophy, which then could be tested by different groups. And we can see,
mm.
what works.
Yeah. So also like fork the state and have like separate validator sets and
Yeah, yeah. I mean, of course, validators could choose
yeah,
which one they want to continue to validate. I mean, there's
yeah,
always this sort of happened with ETH Classic, and
yeah,
of course, like there's a clear network effect to what community works on something. So
yeah,
there are reasons why people might not want the system to fork. So maybe someone would think like, I want CosmWasm, but I'm not willing to fork like this in order to do this. But I also think that splitting the asset as opposed to copying the asset is a really different strategy, because it means that the people who are going to one side or the other like actually want to do the thing, right? Like if you just copy the asset, then all of the people who you disagree with can kind of sell, like they'll just exit. And it creates this kind of very adversarial nature, because there are now two assets like competing to be Ethereum or competing to be Atom. But if you
mm.
just split the asset, and if everyone understands that like this really is a bifurcation in history, it's not, there is no Atom, they're just two different versions now. That's a hard thing to convey, I realize, but I think that would be great if it could
Yeah.
happen.
Well, maybe you can make a proposal to the hub. Yeah, this has been great. Thanks so much for coming on and spending all this time here. This has been really interesting. And I've got like so many notes from this call on things I want to follow up on. And so we'll either do another episode together at some point, or maybe with some of the other folks at Heliax. So thanks again.
Thank you. Cheers.